apnea is a serious sleeping disorder which a person's breathing repeatedly starts and stops during sleep. See, these breathing interruptions can reduce the oxygen levels in the beds and also breathing interruptions. If untreated, sleep apnea leads to severe health diseases such as heart disease and reduce the oxygen levels in the beds and poor concentration. See, this sleep apnea is diagnosed by using a test called polysomnography. This polysomnography is a high expensive, time consuming and not easily accessible to the persons. See, design thinking is of 5 stages: empathy, define, ideate, prototype and testing. Let us discuss briefly. See, empathy will be elaborated by Lakshmi Parvati.
The first stage of design thinking is empathy, which focuses on people's needs who get affected by the problem. People affected by sleep apnea often experiences symptoms such as poor sleep quality, breathing stops in between the sleep and morning fatigue. Many individuals remain undiagnosed due to traditional sleep diagnosis method require overnight diagnosis in hospitals. These processes can be uncomfortable, expensive and difficult for people who live in remote areas. The doctors and healthcare providers also face challenges in treating many patients with limited sleep laboratory facilities. So therefore there is a need for creating a simple, cost-effective, portable and comfortable system that can monitor patients at home and detect sleep apnea events automatically. So understanding these needs, creators can design a system that is cost-effective, small and portable, which diagnoses the sleep apnea events and update the doctors with the accurate data.
In this different stage, the core problems are completely identified as unsafe gatherings from users. The main problem is traditional sleep apnea diagnosis is very complex and expensive and not accessible for everyone. As a result, the many patients are untreated and undiagnosed. The system completely monitoring the breathing patterns and notices the abnormal activities from respirations and alert the users.
As sleep apnea is diagnosed by using the biomedical signal processing. First we are applying the digital signal processing. See, with the help of these sampling, first converting from their analog to your digital signals, right? With the help of sampling those signals. By using this fast Fourier transform that can be converted from your time domain into frequency domain signals for quantizing the biomedical all these signals, right? Why we are using it as your multi-rate signal processing means multi-rate signal processing we can analyze the extract the raw data. We can eliminate the unused data. That's why we can go in for your multi-rate signal processing. With the help of all these BSP techniques, we are using just your biomedical signal processing.
In ideal part, technology solutions are used to solve the defined problem. Engineering researchers are used as wearable sensor, which can collect psychological signals, airflow signal, oxygen saturation signal, and heart rate signal during sleep. These signals can be used as digital processing technique, which is used to breathing pattern. The systems are used as ECG sensor to manage the heart rate signal and microcontroller or BSP signal to control the heart rate signal, and these can be used as digital processing system to connect the breathing pattern in the airflow signal.
So in this prototype stage, a functional model of the sleep apnea has been developed. So these systems consist of the wearable biomedical sensors which can be weared to the patient during sleeping process. So these sensors will collect the physiological signals. After collecting the signals, it will remove some noise with the help of digital filters. After filtering, it detects some abnormalities during the breathing process within the 10 seconds. So it is normal in all the indicators. So after collecting the data, it can be transmitted to the doctors or the patients who can view the results, and it may also generate some alerts during the abnormalities in breathing process.
Sleep apnea detection using biomedical signal processing can be analyzed by using the various components include respiratory sensors, pulse oximeter, ECG sensors, and microcontroller and DSP processors, wireless communication, and mobile patients. See, the respiratory sensors to monitor the breathing patterns, pulse oximeter to analyze the blood pressure and oxygen levels, and ECG sensors for heart activity, and then microcontroller and the signal BSP signal processing for how to monitor the signals from analog to digital converting signals, and also wireless communication for data transmission. We can extract only the raw data, eliminate the other extract data, and also mobile applications for signal processing and monitoring.
The testing stage involves the evaluation of the designed systems from the real users. The prototype is tested with the patients who are affected from the suspected sleep apnea. The results are tested from the laboratory, from the traditional sleep users. The laboratory tests to ensure more accuracy and reliability. Both patients and the doctor feedback has been taken from both the patients and the doctor to ensure more improvement in the system. For example, accuracy, signal processing, etc. Continuous refinement and testing the system helps the system to improve and attain the large scale in the medical field.
Now I am going to explain about the applications part. This sleep apnea detection using the biomedical signal processing represents an innovative solution in the medical science industry. Actually, it combines the medical science with the advanced signal technology, which includes a lot of applications, challenges, and also some advantages. Let's see about some of the advantages and challenges. First thing, it mainly used for the early diagnosis of the patients, and also since it is home friendly, it is remotable, they can use it anywhere else, and also it improves the overall sleep quality of the patient, and also it reduces the expense of the patients, because for this they used to take a lot of tests and lab tests and scans that cost very high. So by using this technology, they can reduce and save a lot of expenses, and also it is mainly used for the continuous monitoring system, as it helps them to increase their overall health. And when it comes about the challenges, since we use the sensor, it has a lot of challenges like some output for delay in accuracy and reliability, etc., etc. And also, since we use the biomedical signals, it contains some noises, which includes delay in processing for large data. About this, I conclude that by using a design thinking approach, the engineers may gather and create a user-centered place so that the patients may mainly focus upon their diagnosis and their comfort, etc.
Now let us conclude the sleep apnea detection using biomedical signal processing. See, this sleep apnea detection can be analyzed by using the test called polysomnography. This polysomnography, with the help of these several steps by using respiratory sensors, oximeter, ECG sensors, and wearable devices, BSP process, we can analyze the sleep apnea detection. See, in biomedical signal processing, sleep apnea can be detected by using these type of various biomedical signals, can improve the quality of life and better sleep for patients. Thank you all.
Thank you.